Hello everyone. Okay, so today we are going to do this is day 1 and we are going to do December 2012. So I will quickly start. We are already 2 minutes late. Yeah. So the first question is this: which of the following number is the largest one? Okay. So the first one, 2 raised to 3 raised to 4, 2 raised to 4 raised to 3. Yeah. So for this type of question, we just have to. Okay. Okay. This is 2 raised to 3 raised to 4, 2 raised to 4, and this, okay, 2 raised, and that is 3 raised to 2 raised to 4. See, in this term, these are the exponential term. The term which has the highest power, that will be the highest power, I mean to say, that will be your, so highest power I can see 4 raised to 3. No, sir. What is 3 raised to 4? Yeah, 3 raised to 4 has the highest power. Yeah, among all of them. So answer will be 2 raised to 3 raised to, that is option 1. Okay, let us go to the next one. What is this? Can you see it? Yeah. Hmm. The cube ABCDEFGH in the figure has an each edge equal to A. The area of triangle with vertices at A, C and F is. Okay, vertices at A, C and F. So we need to find area of this triangle. Correct. Let us see that. First, can you see that we can find the base? Base will be root 2. Correct. Next, here also I can find this guy also. This is again going to be root 2. Here also, no, wait. Where's the triangle? Yeah. Yeah, but the point, yes, this will be also root 2. So that is actually equilateral triangle. Equilateral triangle has area root 3 by 4 side square. Correct. What is side here? Root 2 square. So if I take root 2 square, that will be 2. That is root 3 by 2 will be the answer. Wait. Here, what they are saying? They are having A. Wait, I consider that A. So that is actually not A. So these are, I consider it at 1. So even then also you can see the answer will be root 3 by 2. If I put A equal to 1, then answer will be this one. Yes, or else you can do that. See, I find this is A, this is A, I want to find that. So that will be equal to x square equal to 2a square, that is x equal to root 2a. Correct. The side is root 2a, side square will be 2a square. Yeah, option 2. Okay, let us go to the next one. What is the number of distinct arrangement of the letters of the word UGCCR so that you and I cannot come together? Okay, so you and I cannot come together. That means suppose I am having like this. How many people are there? 1, 2, 3, 4, 5, 6, 7. Correct. Suppose if I have my first position, yes. Wait, let me think. Or else we can say there will always exist a guy in between that. Yeah, that will also work. You and I can even do it. Okay, let us fix a position for u. Suppose u is here. So how many people can sit here except I and how many that? It is 6 people. Yeah, that is 5 people because total 7 people. You and I won't be there. That is here 5. For here it has actually 6. For here now uh, no wait. For here I can be here. Since repetition is allowed or not, maybe we will consider only repetition is allowed for C. Yeah. Okay, then this is 5. This is again 5. This will be 4, 3, 2, 1. Yes, 24 into 25. Yes. 600 this is, and now we have considered fixing u. Similarly we can fix your the second term, that is I. If I fix I, then also I will get 600, that is 1200 total. Now here you are fixing it. Okay, what next? If I put u here, then the actually that same thing is there. Something else, which condition which haven't we haven't used. 1200 is there. See, if I take the repetition, even one more thing. C is repeated twice. Correct? District arrangement letters word is here so that you and I can all come together. Okay, then I will skip that and go for the next first. Suppose the sum of 7 positive numbers is 21. Okay, what is the minimum possible value of the average of the squares of their number? Sum of the 7 positive number is 21. Okay. The minimum value of average of the square of number. See, 21 means it will be n into 7 numbers, so that is 7 into n plus 1 upon 2. They are saying positive numbers, so actually can you see that if I take 7, no, this is not possible. If I take 6 into 7 upon 2, then it is 2 3s are, yes, now so numbers are 0 1 2 3 4 5 6. These are the number. Now what is the minimum possible value of the average of square of the number? So average of square means what? We need to find 1 square plus 2 square plus 3 square plus 6 square upon 7. Yes, upon 7. Correct? But What is this formula? A square, that is n plus 1, 2n plus 1, that is uh, 6, 6 plus 1, 12 plus 1 upon 4, I think. Yeah. No, upon 2. So this will be 7 into 13, yes, into 6 into 3, correct? This was we need to upon 7 also we need to do. Wait, man. Suppose the sum of 7 positive number is 21. So we are having 7 positive number, that is 0. So what is the minimum possible value of the average of squares of this number? Average minimum value, average of squares of this number. Yeah, that is 1 square plus 2 square, 0 square, starting from up to 6 square upon average is 7 divided by 7. So we know that summation k square, that is n plus 1, 2n plus 1 upon 6. So this will be there is actually 7 number, 7 into 7 plus 1, that is 8 into, yes, 15 upon 6 into 7. 7 cancel, 6 can be written as 2 into 3, 3 5s are 15 and 2 4s are, there is 21, there is 21, yeah, we are getting. Here we want least positive number. Yeah, FTD always sucks, man. 1 ratio 13 plus 2 ratio 3 ratio 13 up to 100 ratio 13 upon 100 up to 99 ratio 13 upon 50 up to this upon 50. So we need to find the relation between them, which is the smallest. Okay. See, can you see that uh, this is odd terms, this is even term. So what can I do? I will start with odd term first. Let us see. If I have odd term, what I can make, this can multiply with 2 and I can write it as, if I multiply with 2, that will be upon 100, and inside I will write it as, no, yeah, yes, yes. So this will be E minus, it will be odd even terms, all even terms, so that is actually C, correct? No, wait, A, that is upon 50 will be as it is, that will become upon 100. So we want 50, no? So we need to see it is 2C. So what can you say? B equal to 2A minus 4C. So if I divide by 2 or C, if I put 2A equal to, that is B minus 4, B plus 4C, A will be equal to B by 2 plus 2C. correct? So this is your A, it is addition of this. So can you see that C is the least one, I think? Yes. Yeah. Or let us do one more thing. Let us start with A, split it into two part, that is 1 raised to 13 plus 3 raised to 13 uh, plus up to, that is 99 raised to 13, plus this is your odd terms and this is your even term, that is 2 raised to 13 plus 4 raised to 13 plus dot 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 100 raised to 13. Correct? It is divided by 100. What next? So this will become, can you see that? Yes. This will become uh, B will be become B by 2, plus this will become C by 2. Yeah, this was the problem actually. So here what is A? That is addition of B by 2 and C by 2. Correct? So I can write it as A equal to B plus C by 2. Yes. Okay. Actually, if I take B and C here somewhere, then A is in between actually. Can you see that? Say B and C if I take, then A will be in between. Now the thing is that C and B can be here also. So in which case A is in between CB and CB. Here are two cases. Now we need to understand which one is the bigger. C is bigger or B is bigger than A. So for that let us see. Now we know that this was not going to be our answer. From this and this is going to be our answer. And we just need to have the relation A with B and A with C. Okay. Mm. Let us find C minus A. What will be C minus A? Okay. So what is your C? Uh, 2 raised to 13 plus 4 raised to 13 up to 100 raised to 13 minus upon is this is 50 and minus here 1 raised to 13, 2 raised to 13 up to 100 raised to 13 upon 100. Yes. So let us multiply by 2 with, to solve it we need to make the denominator same. So to make it same, what we are going to do, we are going to multiply with 2 here. So this will become 100 now. So now let us subtract. So can you see that 1 2 raised to 13 will cancel and we will remain with, yeah, will remain with minus 1 raised to 13 plus 2 raised to 13 minus 3 raised to 13 plus 4 raised to 13, like that, and last term will be 100 raised to 13 divided by 100. Correct? So we need to see what is this term. This term is going to be negative or positive. Yeah. Mm, we should have done it. Yeah, I think C minus C will be always positive. Can you see that? The last term is 100 raised to 13. Yes, that will be the greatest one. So this term is positive. That means what? C minus C greater than 0. That is C is greater than A. That is A is in between, C is the biggest. Now option B will be the correct one. Okay, we'll do the next one. A wire of length 6 meter is used to make a tetrahedron of each edge 1 meter using only one strand of a wire for each edge. The minimum number of times the wire has to be cut. So 1 2 where has length with 6 meter is used to make a tetrahedron of each side of 1 meter. Okay, using only one okay, so if I start from here, suppose if I start from here, mm, say 1, yes, say 2, say 3, next say this is 4, this is 5, now I need to cut, say see this is 2, only one cut required I think, yes, option C. Okay, let us see the next one. If the sum of the next two terms of the series, the below is x, what is the value of log x to the base 2? Okay, so what is given, let us observe the series. 2 minus 4 8 minus 16. Mhm. Yeah, it is table of 2. See, this is 2 raised to 2, 2 raised to 3, 2 raised to 4. No, that is 2 into 4. That is multiple of 2. So, it's 2 into 2, 2 into 3, 2 into 4. Wait, man. It is table of 2. 2, 2 square, 2 cube, 2 raised to 4, 2 raised to 5, 2 raised to 6, 2 raised to 7 is given. Next term will be 2 raised to 8 and 2 raised to 9. Alternate plus sign, we started with plus minus plus minus plus minus plus minus plus. So we need to have this. So take 2 raised to 8 common. We are getting 2 raised to 8. Log 2 answer will be 8. Option 4. Yes, option 4 will be the 8. Let us go to the next one. Fast, what is the time? 55, man. What are you doing? A conical vessel with semi-vertical angle 30 degree and height 10.5 centimeter has a thin lid. A sphere kept inside it touches the lid. The radius of the sphere in centimeter is okay. The height is total height is 10.5 centimeter. Okay. And a sphere kept inside radius of the sphere. Okay. Hmm. So if I try to see this, this will be the diameter. The in point will be something will be the remaining part. Vertical. You need to use this angle 30 degree. Uh, I think I remember some formula. If there is a sphere and something like this, then the ratio of this used to be. But here we are getting the angle actually. We are giving this angle. This is slant height of that sphere, and See, let us see by option. If I see, so radius, if radius is 5, 5 plus 5 10 होता है, so उतने का तो मतलब 0.5 थोड़ी है यहाँ पे, and this is 6 6 12 12 पॉइंट ज़्यादा हो गया, स्पीयर ऊपर जाएगा 7 7 ओके, फ्रॉम ऑप्शन इट वाज डायरेक्टली क्लियर मैन, ऑप्शन ए इज करेक्ट, if you read the option then it is quite clear. Okay, 10 Amar Akbar Anthony was the 3 point. Just this is quite simple. Just you need to write the them. Okay, let me do the question number 11. We are having very less time. Hmm. If 10 cats catch 10 mice in 100 minutes, okay, 100 cats catch 100 mice in 100 minutes, then how long will it take for 7 cat to 7 mice? 100 minutes only. There are 100 cats, 100 mice. They took 100 minutes. Correct? So there are 7 cats, 7 mice. They will again take 100 minutes only. Yes. What is next? Yeah, this is quite good. So they want to ask that what is this formula. So suppose we want to find the whole area. So this is actually n plus 1. That is only n into n plus 1 by 2 something. If I find the area of these edges, if I find sum of them, then this will be this. But here I am having 2 times of that, I think. Yes, yeah, that's it actually. N into n plus 1 it will work if you start counting this. Correct. So I think first option will be the correct one. Next, let's go to the next one faster. At which time? At what time after 4 o'clock the hour and minute hand will lie opposite to each other? So after 4 o'clock, correct? Suppose this is 4 o'clock and they are saying suppose this is 12. Exact 4 o'clock, this is what I'm saying. At what time hour and minute hand will lie opposite to each other? Hour and minute hand. So that will be again 4 o'clock. Minute hand, it will be minute hand will go somewhere here. Right? That means it should make 180 degree. Yes. 9 around 55. Yes, that will make angle 0 actually. Yeah. I think 54 and 30 minutes actually. Looks much closer to 55. Yes, to me. Other than this 50, 52 and 53. So I'll go with that. Let's go to the next one. I'll just take 5 more minutes for this because it's for the request. Which of the following curve just touches the x-axis? Just touches the x-axis means what? Its derivative is 0. Something like this. Just touches the x-axis. Correct? That means it should satisfy, should give x equal to 0. Yeah, because at this point actually your function y equal to 0 and x equal to something. So let us put y equal to 0 and which of them has the solution. If I put y equal to 0 here, what will be the solution of this? No solution. Y equal to 0 if I put, then What will be the solution? X square minus 2x plus 2. Here I think this will have a solution. No, I think this won't be have a solution. Y equal to 0, 15, multiplication 15, addition 10. So 5 5s are 10. Yes, 5 5s are 15. That is x square minus 5x plus 25. Yes, this has a solution. This touches. What about this one? We have got our answer option 3. We won't go to that actually. Even you can do that b square minus 4ac and all, and also you can get it. If AB is parallel to CD and EO equal to 2OD, yeah, AB is parallel to CD and EO equal to 2OD, EO equal to 2OD, okay. Then the area of triangle OAB, is bigger than area of triangle OCD by what factor? Okay, now what factor? So what do we have? U equal to 2OD. Yes. So if I take this is x, this will be 2x. And these are the parallel things. EB and parallel AO equal to 2, then area of triangle OEB bigger than area of by what factors. So according to me, if I take it as an equilateral triangle only, so area of this will be root 3 by 4 side square, and let us take and this will be root 3 by 4. What is the side? X square. This will be 2. It is 4x square, correct? These all get cancelled. Yes, this is 4. That means 4 times according to me. There is option 3. Yeah, okay. Let us go to the next one. A semicircular arch of radius r has a vertical pole put on the ground together with one of its legs. Okay. An ant on the top of the arc finds the angular height of the tip. Find the height of the pole. Okay. Vertical pole put on the ground. Okay, together with one of these legs on the top. Find the height. We need to find this height of a pole. Correct. So this is perpendicular, and this is actually r, and there it is gained 45 degree. Correct. So if it is 45 degree, no, actually we want to find the height of. No, actually, can you see that this is one end, means the first end, this is radius, then diameter will be 2r. It is just greater than 2r. Yes. No, it is actually 2r only. It will be actually 2r only. That is root 4. Correct. The focus was here. Focus should be here actually. It was one end of that. Okay. What is the next? Suppose we make an identical sphere from a big sphere. The total surface area of the smaller sphere of x times the total surface. Okay. So let us see that. Suppose we make an identical similar spheres with a big sphere. Suppose I am having a sphere, volume is 4 by 3 pi r cube, and that is equal to n times 4 by 3 pi r cube. Okay. the total surface area. Okay, we should have solved the surface area. The total surface area of the smaller sphere. Okay, so that is 4 pi r square, and here it is 4 pi r square. That is, this is smaller, this is greater. What is the total surface area of smaller? Here is, yeah, that is actually x times the total surface area of smaller. Total means what? Adding all term, that is x times. So what is x? Yeah, so from here you can see that x r square equal to n r square. From here we will get the relation between r and n, and here it is giving me r cube equal to n r cube. Yes, so what next? No, cube root of n. Here if I try to find the value of r, no, or just divide it with this. So what will be your value of r? R will be cube root of n into small r. Let us substitute it here. If I substitute at the place of r, it will be x into, this is cube root, that is n raised to, it will become 2 by 3, yes, into, that is r square will get cancelled, that is n. So x will be n 1 minus 2 by 3, that is 1 by 3, that is cube root of n. That is the answer. Cube n raised to 1 by 3 will be my answer. Yes, what is the next? Man, it is so sad. I have taken 40 minutes for this. What is the next number in the sequence? 24, 30, 33, 39, 51. 24 and 30 and 31. 30, let us see the difference. Here it is 8, here it is 3, here it is 6, here it is 51 minus 39, and that is almost, I think, 20. What is it then? Let us think something else. 24, yes, ah, I think I got something. But next term, I think it should be 5 into 7, I think it must be. Okay, let's go to the next one. 4 lines are drawn in a plane and with 2 parallel and no 3. The lines are drawn the intersection of the number of new lines of in. Okay, I'll skip this question. Let me start with our mathematics part. What is the first one? F be the twice differential function given that f double derivative is greater than 0 for all x belong to R. What can you say about this? Correct. That means minima f of x equal to 0 had exactly two solutions. F of x has the positive solution if f of 0 equal to 0, and f dash of 0 equal to has no positive solution. Okay, I think we should have an example here. Suppose f double dash of x तुम्हारा है 2. So f dash of x, it will be 2x plus something k, and f of x must be something x square plus kx plus c. So this is your function. What can you say about this function? So they are saying f of x equal to 0 has exactly two solution on R. Okay, so exactly two solution on R. Is it true? Okay, we will think about it. Let us go to the next one. They are saying if f of 0 equal to 0, that means your c equal to 0, and f dash of 0 equal to 0, that is k is also 0, means your function is just x square. Then f of x equal to 0 has a positive solution. No, this is wrong. What is this? If has no positive solution, e positive solution means, but x equal to 0 is a solution. Yeah. Correct. Okay, what is this next? F of x equal to 0, no positive solution. If f of 0 equal to 0, correct. If I take f of 0 equal to 0 means c is gone, and f dash of 0 is greater than 0, means your k is positive here. So your function is x square plus kx. This is your function. What can you say about this? This is x into x plus k, and its root are x equal to 0 and x equal to minus k. But it has no positive solution if f of 0 k. So it has no positive solution. What are the solutions? 0 and minus k. Correct. Positive solution. Yeah. Okay, then I think that we should go with this only. So ये true है, तो this is false, because these are the negation of that exactly two solution. This need not be, I think, because if I take e raised to x, it has no solution. Okay, let us go to the next one. I think this is quite repeated question. Let f be the continuously differentiable real valued function on closed AB such that mod of f dash of x is less than equal to k for all x belong to AB. For a partition is given, let UPF and LPF be okay, upper sum lower sum okay. Then they are asking about this. Yeah. So one thing is that, so mod f dash of x, mod f dash of x is less than equal to k, correct? So that means for some y, f of x minus f of y, that is less than equal to k into x minus y, something like this. Take mod here over this. So what is the question? LFP will be less than equal to k times k times p minus e, or I think I should use some putting some value of k. If dash of x equal to k दिया, then your function will be that. Yes. That is actually integrable, that is for sure. So integrability tells only 3 and 4. EFP minus LFP, that is less than k. Norm P, what is mod P? Maximum between AI plus 1 minus AI. That is, I think this is okay. K into B minus A will be there for this and this. I think option 4 must be true. Yeah. Okay. FB a monotonic non-decreasing real valued function on R than what? See, monotonic and it is non-decreasing. Correct? So limit extending to a bola f of x exists at each point. No, if we have step function that limit will be different. If a is less than b and limit of extending to a plus f of x is less than equal to limit extending to b minus f of x. Monotonic increasing है तो I think this must be true. F is an unbounded function. The function e raised to minus is bounded. This is not bounded. I think option 2 is correct one. That actually tells the uh, step function satisfy this and step function is monotonic non-decreasing. Okay. Let f be a real valued function on R3 satisfying f of Rx equal to, yeah, that seems quite good. So f of Rx equal to R raised to x f of x. So that is something like f of x equal to, अगर मैंने क्या लिया norm x or something, let me see the option. If f of x equal to f of y, whenever norm x and norm y equal to beta, then your f of x will be something like this. Okay. The thing is that, see, f of x is something times norm x, that is true. F of x something times k times norm x, but here r raised to alpha there, so it will be actually raised to alpha. So if I take f of rx here, yes, what will be f of rx? That will be r, yes, that will true, that will satisfy. Okay, this is true. So what they are saying, norm x norm y beta है तो this will be alpha plus 1 ना, ऐसा क्यों लिखा. Next option 2, norm x raised to alpha, rx लिया तो that will be r raised to alpha norm x raised to alpha. This satisfy, this is okay. Yeah. What is the third one? This is equal f of x equal to c times, yeah, for some constant. Yes, this is also true. So I think 2 and 3 both are correct. This is same for some c and this is for c equal to 1. But c is not in general, so we cannot log this. This is more correct than that. And here f need not be a constant. Option 3 will be the correct one. Next. Okay, what is that? Which of the following real valued function on 0 1 is uniformly continuous? Okay, this is open interval 0 1. So the thing is that function must be continuous and limit must exist in the both at 0 and 1. So if I take limit at 1 was, so it is not. What about this? Yes, this is okay. What about this? Cos 0 upon 0. No, no, no. No, no, no. What about this sine 1 upon x? It is bounded. Yeah. No, I think it does not exist at 0. This is also, so this is the correct one. Option 2. What is the next one? Let x be the metric space and A is subset of x. Be connected set with at least two distinct points. Okay, the number of distinct points in More than 2 but when it countable. Uncountable man, take a real number system. If you say connected, their connected things are interval. So that must be uncountable. Option 4. 26 4. Okay. 27. What does this says? Hmm. Where is the question? It is here. Let me keep it like this. Yeah. Let n be the positive integer and mn denote the space of all n cross matrix with t is a linear such that t of a equal to 0 whenever a belong to mn r is symmetric or skew-metric, then rank of t will be what? Okay. So they are saying whenever a is symmetric or skew-symmetric, your t of a equal to 0. Yes. So what is the rank of t? T of a is 0. Your t is only 0, so linear transformation here, so that will give a 0 matrix only. Option 4 must be the true one. Yes, rank of t must be 0 only. Okay, what next? Let S from R3 to R4 and T from R4 to R3 be linear transformation such that T composite S is identity map in R3. Then what can you say about S composite T? Okay. Yeah. Let us see. Let us have an example. So suppose they are saying T composite S is identity map. Hmm? Then S composite T is also identity. S composite T is 1 1 but not on 2. S composite T is on 2 but not 1 1. Yeah. S composite T is on 2 but not. T composite S is identity. If I take identity function, then everything is true. That is option 1. Linear transformation such that T is identity. That means actually T and S are inverse of each other. So does that mean S and T are also inverse of each other? No, actually here ordering are different, man. See, what will be your S composite T? That will be R4 to, yes, R4. It will be a 4 cross 4 matrix. What is T composite S? Here this is R3 to R3. We are extending it to R4 to R4. This is identity map. Will that be an identity map? So let us try to see an example. Suppose S equal to, if I take X, so what is the identity of this? X inverse 1 by X, but this won't be because 1 by X not a linear transformation. Correct? There should be linear transformation first. I think it is not an identity. What about 1 1? Yeah. 4 to 4. I will go with this option number 4. Neither 1 1 nor 2. Okay, let us go to the next one. Let V be the three-dimensional vector space over field Z3 with here number of distinct one-dimensional subspace of B. So I think I know the formula for this. Number of distinct one-dimensional subspace. It has something. What was the formula? Something like that. P raised to n minus 1, P raised to n minus P, P raised to n minus 2 square, and like that up to P raised to n minus P raised to n minus 1, I think. Yeah. So here what is your P? P is your field, and here that is also 3 only. Yes. Was this the only? I think it was P raised to n minus 1 upon P minus 1. Let me just think about it. Yeah, I think it was P raised to n minus 1 upon P minus 1. Yes, because one dimension. Yes. So that is what 1 plus P square up to P raised to n minus 1. Correct? So what is here? It is 1 plus 3 square. Yes, that's it. So what will be that? 4 plus 9. That is 13. Option 1 will be the correct one. 13. Yeah. Yes. What is the next one? 30 question number. Let V be the inner product space consisting of linear polynomials P from this to this of the form Ax plus B, and it is defined as inner product of P and Q. So they are asking an orthonormal basis. Orthonormal means what? Let us see that. We just need to say whether first they are orthogonal. 1 into x, if I take, it will be x, and x 0 to 1, that will be 0 to 1 x square by 2, that is not 0, so this is not orthogonal actually. What about this 1 into x, that will be x square by 2, that won't be. What about this? Let us see. Integration 2x minus 1, take root 3 outside, I think this will be 0. Root 3 into this will become, yeah, x square by 2, that is x square minus x 0 to 1, that is if I put 1, if I put 0, in the both the cases answer is going to be. So this is orthogonal. First condition is okay, orthogonal का है. What is next? The next thing is that check whether orthonormal or not. Now let us check whether this is orthogonal. X minus half, that is x square by 2 minus half x. Yeah, I think this is also orthogonal. So we are having two options now. Let us check this one first. Can you see that? One. It is now what? That is orthonormality. So this is 1, then that is okay. This will be 1 only. Let us see this x minus half. If I have x minus x is x square minus x plus 1 by 4. Yes, that is, take the integration, this will be x cube by 3 minus x square by 2 plus 1 by 4 x. Put the values 0 to 1. If I put 1, this will be 1 by 3 minus 1 by 2 plus 1 by 4. That is not going to 1, that is for sure. So option 3 will be the correct one. Yes. Let us go to the next one. Let f of x be the minimal polynomial of the 4 cross 4 matrix E So this is your matrix. So then the rank of 4 cross 4 matrix, rank of, let f of x the minimal polynomial. So first we need to find the minimal polynomial of this. Correct? What can you see about this? Mm, Polynomial. Then what is the rank of 4 cross 4? See, if it is a minimal polynomial, man, it will be 0, yaar. Minimal polynomial satisfy that equation A. So option first one will be the correct one. That was quite simple. Let us go to the next one. 32. So 32 bar 36. We should have taken 36 minutes. I think we have covered our time. We are having 3 minutes left. A, B, C are the positive real numbers such that B square plus C square is less than A, that is less than 1. Okay. Consider the 3 cross 3 matrix E equal to this 1 B, B C, C0 1. All the eigenvalues of A are negative and real number. E can have a positive as well as negative eigenvalue. So we need to find the eigenvalue. Okay, so just find the determinant first. Let us see. The thing is that this is actually symmetric matrix. Okay, what will be determinant? Let us find C into, I am finding from last row, C into, that is 0 minus AC, and that will be next gone, plus 1 into E minus B square. So what I am having, minus what was this, AC, no? That is minus AC square minus, oh, that is plus A minus B square. Okay, what do we have? B square plus C square is less than A square. Okay, that is less than A. If I use this, see, B square plus C square is less than 1, so B square is less than 1 minus C square. Okay, yeah, but I have, yeah, if I take A common, I will have 1 minus C square minus B square. Now 1 minus C square, that is greater than, so this will be less than AB square minus C. Yeah, then A B square minus B square. If I take B square common, now that is actually B square, that is E minus 1. So what can you say about E minus 1? That is always going to be negative. So this term is going to be negative, and it is negative greater than that negative value actually. Yeah, because B square is always going to be out. So this is E minus 1. So all the eigenvalues are here for negative and real number. Yeah, I think option 3 must be true, because yeah, if it also given a positive, actually we should be double sure. Just let me do it once again actually. Maybe I should put some values. If I put some values, say B and C as 0 0 and A equal to 1 by 2, so this will be 0, this will be 0, uh, and this will be 0, this will be 0. A is 1 by 2. So can you see that the eigenvalues are all positive? Yes, in this case we got all positive. That is option B. If I take another example, if I take B and C, see 1 by 2, 1 by 2, no, 1 by root 2, 1 by root 2, then also it will become, just take something else, 1 by 4, 1 by 4. Yes, so I think then also it will going to be positive only. Anyway, this is a symmetric matrix. It has real root and it will be positive. Complex तो आएगा नहीं गया ये. What are the next? Okay, I think we are done with this. Let us go to our part, that is question number 61. Where is that? Yes, here. Okay, the first question. Fn be the sequence of continuous real valued function on 0 to infinity. Suppose fn converges to f of x for all x belong to this, then f is integrable. So then that f is integrable, then what? Integration होएगा क्या? For all x belong to this. If fn is uniformly, yeah, that is true. If fn is uniformly, then that's what no. No, infinity पे नहीं होता. It is this. If integration is this, then this. I don't think so. This is true. Yeah. This is not. What is this? Directly saying no. If your function is uniformly continuous and on a bounded region 0 to 1, then this is true. Okay. Let us go to the next one. Let x be the compact topological space and f from x to r be a function. The graph of f is set g equal to x comma f of x. So this is your graph. Okay, which of the following is necessary? So graph is a closed set, that is actually seen from here. A closed set if and only if the function is continuous. No, if suppose function is continuous, then it is closed. Okay, this is true. If continuous, then it is connected, need not be, man. If and only नहीं रहेगा. If it is closed, then doesn't mean that function is continuous. If function is bounded, continuous function. So if it is bounded also, and since continuous, then it is closed and bounded in R, so it will be compact. Yes, so compact it was on compact topological space, so you can say that closed subset of compact topological space is compact. Yes, let us go to the next one. Yeah, what is this? Suppose f from R to R be a differentiable function, then which of the following statement is necessary to differentiable function? If derivative of f is less than 1 for all x belong to R, then f has at least one fixed point. Yeah, at least one, it has actually unique fixed point. Option 4. Yes, function complete and R is complete. Yes, if f has unique, that I think at least में one तो आता है ना, so I can say that it's also. And इसका convert, no, this is not true. And what is this? -1 से बड़ा, no man. So if a function is, then it has at least one fixed point. It has actually unique fixed point. Okay, let us see the next one here only. Which of the condition below imply the function is necessarily bounded variation? Okay. Mm, bounded derivative, yes, bounded derivative. Monotonic, yes, monotonic. Continuous and monotonic. If it is monotonic, then it is also true. Continuous monotonic, then it is also true. Has derivative से क्या लेना देना है? So it has option 1, 2, 3. Yeah. What is the next one? 65. F of x equal to sin x minus x plus x cube upon 3 factorial and g of x equal to this. Which of the following statement is correct? First one is saying f of x is always g is increasing, g is decreasing, f is decreasing. So for decreasing increasing we should find the derivative, but first thing is that if I take x positive then function is always going to be positive. Let us see that. So suppose if I take x equal to 0 then it is okay, but if I take x equal to 90 then this will be sin 90, that is 1 minus pi by 2, and that is pi cube, so that will be positive actually. Yeah, something else. Hey, wait man, this is actually expansion of sin x. See, sin x is equal to odd power, no? X raised to 1 minus x cube upon 3 factorial plus x raised to 5 upon 5 factorial, like this, correct? So what can you say? Sin x is always greater than, if I take only two terms, x minus x cube upon 3 factorial, if I take them that side, that is sin x, yeah, this is greater than equal to, that is sin x minus x plus x. So first one is true, correct? What next? G is increasing function. Let us see what g is. See again g, can you see that? This is cos x expansion. Cos x equal to 1 minus x square by 2 factorial. So this is actually uh, wait man, but that was alternate and I did only two terms. Yeah. For all x positive, increasing, okay, for increasing we just find the derivative. That is derivative of cos will be sin x minus sin x, and it will be plus x minus sin x plus x. See, sin x is always one. Yeah, this is always greater than equal to 0. Why? Because x is always greater than sin x. So g is increasing. Yes, this is true. F of x is always greater than 0. Uh, function is always positive. G is decreasing. Increasing है तो decreasing क्यों रहेगा? F is decreasing function. Find the derivative. Sin derivative is cos, and here it is minus 1 plus 3x square. No, that is positive term actually. That may be positive or negative depending, so we cannot say. So answer will be A and B. Okay, let us see the next one. Data from A union E. Okay, I think I have seen this question somewhere. Be differentiable where E is this and E is this, and df be the derivative of function. Which of the following is necessarily true? Derivative of for all x y belong to this, then f is constant. See, the question is that that must be complete. So that interval must be actually complete. So what is this? This is okay. If it is on A, because A, can you see that this is actually complete? If it is on E, then also it is okay. But if it is on union, then that will be a problem. What this is saying, derivative will be 0 for all x y. Then for some it will be 0, and for some it will be x1. Yeah, this is true. Correct. If it is on union. Yes. Because at half we don't know, man, what is the value. No, but it's not required actually. There are two rings. This is circle, open disk, open circle, and this is disk. Correct. Let us see the next one. What is that? Let L from Rn to R be the function such that L of x equal to inner product xy for some inner product on Rn and y is fixed vector in Rn. Further denote dl be the derivative of L. Which of the following is correct? So as usual, what is our formula for derivative? What is this thing? First one, dl of u equal to dl of v for all u comma v belong to Rn. U comma v is anything. जो और v कौन है भाई? Are we given with u only? dl of u equal to dl of okay, we'll see about it. Next, let us find what is derivative dl at 0 0 0. So this will be they haven't told me on at which point. See, we know that how to find the derivative of that inner product. So that is actually inner product of xy. That is x and that point say b, and this will be plus e at point y. This will be your derivative. Correct. Now what is your e and b? If I take it is 0, then what will be this? But why this is there? Wait a minute. This is n-dimensional, man. Okay. So if I put 0, but they are giving only one vector at one vector. So it means if I put my e is 0, if I input my n is to 0 y, or this will be x0, that is your xy again. So I can say that option 2 is correct. Yeah. If option 2 is correct, then is it true? Yeah, I think this will be true for anything, because derivative of that will be derivative dl at, yep, derivative of L. Yeah, and let us go to the next one. F from pi to 2 pi, that is only half circle. F of t equal to cos t sin t. Which of the following are necessarily true? The first one saying there exists t belong to pi to 2 pi such that f derivative, that is I think they are using the LMBT. F of 2 pi, yeah, that is true. First one is okay. There does not exist y, buddy. There exists t naught belong to this such that norm of f of t y minus f of e, what will be the derivative? Cos derivative is minus sin, sin is cos. Yes. So this is okay. Remind. Where is that? This is okay. There exists T naught such that this. Wait, let me think about it. Yeah, actually, the function is not direct derivative, something like that. This is not real valued function. This won't be. Oh, sorry. Option won't be true. So option 2 must be true. What is this? Yeah, this is okay. Yes. Okay then. Yeah. What is the next one? 69. Mm, if your x is this, a is this, set of all x belong to this only, such that x square plus y square equal to 1. That is circle. Yes. And what is this saying? Your mod x plus mod y. That is actually they are saying it will be x mod y. Yeah. A rectangle like this something. Something like this. This will be your B. And what is your A? A is your circle. What is your C? Xy equal to 0 means either x0 or y0. Then that is either this or this. A line only. What is your D? So this is not compact. What is your D? X equal to plus minus y. That means what? What is your x equal to y? Either this or this. So these two are homeomorphic. Sorry, actually there was some technical errors. So we are done with 69 question. Let us go to the next one. Right. Yeah. What is the next? Question number 70. Let n be an integer. N is greater than or equal to 3. Un u to un be n linearly independent element in a vector space over R. Let u not equal to 0 and un plus 1 equal to u1, and your vi equal to ui plus ui plus 1 and wi equal to, okay, so v1 up to vn are linearly independent. So let us see now what will be your v1. See what is your u1 u2 un. So actually u1 u2, this is same as from here also, u1 u2, like this. At some point they will have same value. It will depend on even or odd. And what is your vi? Vi is your addition of ui and ui plus 1. That is addition of u1 plus u2. This. So vi will be also same. Vi will be also like this. v1 v2 up to here it will be v1. It will be v2 and like this only. Both will be same. Here also. What is next? wi. What is wi? ui minus 1 and ui. That is again same only. So wi will be again like this only. So what is the condition? v1 v2 vn are linearly independent when n equal to 2010. So if your n is 2010, yes, up to 2010, vi up to vn they are asking. Let us see What will be my V1, V2, V3? Correct. What is my V1? That is U1 plus U2. U1 plus U2, and it will be U2 plus U3, U3 plus U4. Can you see that if I subtract this through, then I will get U1, U3? I don't think so. But after that, there will be some term. See, if I find Vn minus 1, what will be that? That will be Un minus 1 plus Un. Correct? But you know that Un will be in 2010, so Un will be same as U1. This is U1 and this is U2. Correct? So Vn minus 1 is actually same as U1 plus U2. So option 2 will be correct. Option 1 will be false. So from here, okay, then option 2 is correct. Let us see about W in equal to 2010. What is the W? W is Ui minus 1 to Ui. Okay. So if I try to find U0 is 0, okay. So U1 will be, W1 will be U1, W2 will be U1 plus U2. Okay. Wn minus 1, yeah, this will be linearly independent. Yeah, it will be always linearly independent. Yes. Okay. Okay, then let V and W be the finite dimensional vector space over R, and T1 equal to V to V and T2 will be W to W with an linear transform whose minimal polynomials are given this. Okay, and T from V to W, yeah, with the linear transform defined by this. Then let f of x be the minimal polynomial of T. Then what do you think the degree of this will be? Yes, it is T1 comma T2, na? So that is actually, this is minimal. This will form a matrix. Here this will be having matrix. Here this will be your matrix. This is minimal polynomial of this, minimal polynomial of this. For them it must be, I think, the first thing is they are asking degree and nullity about. Okay, so let me see what was our V. The minimum. What was the dimension of V? They didn't tell us. So that is 3 plus 4, 7. If I take it, then it is 7. And what is it? Your VW is 1. X cube x raised to 4. Yes. If I try to solve this, then you see that I can take x square common here. So this will be x plus 1 plus 1 x plus 1. So this will be x square plus 1 into x plus 1. Okay. What about this? X square minus x square minus 2 relation to, yes, x square that is minus 2x square plus x square minus 2. So that is take x square outside, this will be x square minus 2 plus 1, this will be x square minus 2. So this will be x square minus 2 into x square plus 1. Can you see that x square plus 1 is in both the case? Yes. So we will cut 1, take the product, that is your least common multiple or greatest common divisor, that is what is the degree? 5. Degree of f of x is 5. Yes, option 2 is correct. Degree is 5. Yes. And what is nullity? Rank plus nullity equal to degree, dimension of that v plus w. See, if your minimal polynomial is degree 5, and that is v plus w. Okay then, I think nullity will be 0. I will have to think about it. What is the 73? This is the one. T of x y equal to x plus b, x plus b for x, and T of c equal to x plus. Okay, this is quite seems to be simple. S is always C linear, that is S of z1 plus z2 equal to. Okay, let us see. If I take S of z1 plus z2, that is x1 x2. So that will be e times x1 and y1. Yeah. No man, that won't be. So this is gone. What is the second one? If b equal to minus c and d equal to a, I think b and c was the problem there. Then it may be yes. What is the next? Is C linear only if b equal to, yeah, only if, yes, correct. 2 and 3 are the correct one. C, it is if T is identity transformation. No man. See, if it is identity transformation, then what is the relation between A, B and C? It won't be that. Yes. So let us go to 70. Let A be equal to AIJ. Let star denote the conjugate transpose. Shall the following statement are true. If A is invertible, then trace of A star A is non-zero. Then that is the trace of A star A is non-zero. If trace of A star A is non-zero, then A is invertible. If trace of A star A is less than or equal to n square, then each Aij is less. Oh no, for some Aij it is less than. Trace of A star A equal to 0, then A is a zero matrix. Okay then. So suppose if I take it as a matrix whose diagonal element are 1 omega omega square, like that. So in that case the trace is 0, but your matrix is not 0 matrix. So option 4 is gone. No, they are asking about A star A, not A. So what will be my A star A? 1 square omega square. So it will be square of them. Yeah. Let me see, 41 omega omega square. 1 omega square and omega 4 will be, no, it will be again, it won't be 0. Wait man, I think trace is 0. If the trace is 0, then but instead transpose to the point necessary to phi is invertible, then trace of A star is non-zero. If trace of A star is non-zero, then A is invertible. This is not true. If trace of first one seems okay. If trace of mod of trace of A star A that is less than n square, then each A is a okay. I think this is true. So I will go with the option is 1, 3 and 4. Okay, let us go to the next one. Let n be the positive integer and v be an n minus 1 dimensional such that e of ei equal to ei plus 1. Actually this seems to be mm, nilpotent matrix. So trace of t is non-zero, that is wrong. Rank is t, no. Nullity is 1, that is true. Option 3 is true. And t raised to n equal to this is equal to 0 map. Yes, option 4, 3 and 4. Which means null and the positive integer with a linear transform satisfied by t of ei equal to ei plus 1 means if you are having 1 0 0, then that will go to first one will be your 0 1 1 1, sorry 0 1 0 0 0 0. Next, if you are having t of 0 1, it will give me 0 0 1. Yes, next it will be 0 0 0 1 like this. Yes. So what will be the answer? Rank won't be n. Wait, but this is n plus 1 dimension, no? So rank will be n. Yes, correct. And nullity of t is 1, that is correct. And what is it? T raised to n. No, t raised to n won't be 0. T raised to n plus 1 will be 0. Okay, so option will be 1 and 3 only. Sorry, 2 and 3 only. Because t raised to n plus 1 will be 0. So order of matrix, order matrix, if it is nilpotent, then a raised to n equal to 0. Okay. What is next? Let A and B be the n crossing real matrix such that EB equal to BA equal to 0 and A plus B is invertible. Which of the following is always true? Then rank of A plus rank of B, C, AB equal to BA equal to 0 and A plus B is invertible. Okay. So we need to actually find some matrix for that. If A plus B is invertible, then what about A minus B? Yeah, that will also be invertible because I can write A minus B in terms of A plus B. So option 4 is correct. Yes. What about rank A plus rank B equal to n? E plus B, nullity of A plus nullity of B equal to n. Rank A equal to rank B. So the following is always true. Yeah. AB equal to BA equal to 0 and E plus B equal to this. See, a plus b is invertible. That means what? The rank of a plus b is n. Okay, and ab equal to ba equal to 0, then rank will be normal addition, rank a plus rank b equal to n. So option 2 is true. If 2 is true, then option 3 is also true. So for this 70, for option 2, 3 and 4 will be the correct one. 2, 3 and 4. Okay, let us go to the next one. Yeah. Let n be the integer and greater than m and denote the vector space of n matrix and b such that where b belong to be the orthogonal matrix and b transpose denote the transpose. Consider wb that is given by b transpose ab. Which of the following is necessarily true? wb is subspace and dimension of w is less than rank b. W is subspace, w equal to m and r. wb is not a subspace. For subspace, let us check. If I take e plus b, yes, then that will be okay. Yeah, constant, yeah, it is subspace. Yes. So what is the remaining? Subspace and dimension of wb will be rank b into rank b transpose. That is C n orthogonal, so that is n square. That is true. It is n square and it will be actually equal to m and r. Option 2, 3, 4 will be the correct one. Yes, 2, 3, 4. Okay. What is the next one? Let A be 5 cross 5 skew symmetric matrix with trace in R and B with interest in R and B with the 5 cross 5. ये skew symmetric है, so determinant is 0 for this. Rank will be something less than n. And B be a 5 cross 5 symmetric matrix whose ith are binomial coefficient. Okay, consider a 10 cross 10 matrix. This is your matrix. What they are asking, we need to find the determinant of them, so that will be directly 0. Can you see that? Because that will be determinant of A into B. Yes. So 77, option 2 is correct. What will be trace of A and trace of B? But what is trace of A? That is 0. Trace of B will be n, that is 5. So 2 and 4, 77. 2 and 4, correct. Yes. What is next one? Let A is a 3 cross 3 symmetric matrix such that x y e1 e x y1 equal to xy minus 1. Okay. Let P be the number of positive eigenvalues of E and Q equal to rank of E minus P. Then what is the value of P and Q? Q means the negative eigenvalue, I think. Yeah. So let us see. This is xy1. This will be your matrix something, and this is again xy1. This is giving me xy minus 1. Correct? P be the number of positive eigenvalues of A. See, one thing is true. If P equal to 1, then Q will be 2. If Q equal to 2, then if P equal to 2, then Q equal to 1. Okay, so we just need to find a matrix. If I try to have a matrix, we want one. If I take identity matrix, let us see. Does this have first row, first column? It will give me X. Yes. Next Y. Next 1. What about this? This will give me X square, Y square, plus 1. No, this won't be. mm, this won't give me or so. We want first row first column, it will be x. It want x with y na. mm, so what should it take 1 here, put it 0 here, so it will be first row first column, it will give me y. Okay, and here it will be x. Okay, we got xy. Other terms we want minus 1 na. So in the last mm, last yes, put it minus 1 here and put everything 0. So this is your matrix. I think this satisfies. Let us check. First row first column, this is giving me y. First row second column, this is giving me 0. First row third column, that is giving me minus 1. Let us multiply with x y 1. What will be this? X y minus 1. Yes, we got our matrix. What is that matrix whose rank is 2? Number of positive eigenvalues is, see, there are 1 negative eigenvalue, 2 positive eigenvalue. Yes. So what is the rank here? Rank is 2. 2 minus number of positive eigenvalue. Yeah. This matrix satisfies, but this matrix is not symmetric, man. Can you see that? Question was saying it must be a symmetric matrix. We got a matrix that is something like this: 0 1 0 and here minus 1 0 0. Correct? So we must be having something like this. Now let us check whether, I think this won't be now. First row first column, it will be y. So here it will be y and here will be x. Here will be minus 1. Here again xy1, this will be xy plus xy minus 1. So we want that. What should we do? If I take 2 here and if I take minus 1 here, then I think it will work. Let us check. First to first column, it will become 2y. It will become minus x. It will become minus 1. Okay. What about this? First to first column, yes, this will become 2xy. This will be minus xy minus 1. Very nice, man. We did it. Hey, this is not a symmetric matrix. Man, I will die with this. This is time is going. Give the number of positive eigenvalue. That is rank. Addition is 3. That is okay. Hey man, uh, let me try one more thing. No, I know something. If there is a function which is xy minus 1, so what we used to actually write it in terms of x square, y square, z square, something like that. Xy minus 1. What should I do now? We don't know the eigenvalues actually. This is Then I will stop wasting the time. I will put the answer in that. The answer is 1 and 3. Okay, thank you so much.